Welcome to the lecture number 11 on logic. So in today's lecture, we will discuss about arguments and their validity. So let us begin this lecture by defining what an argument is. So an argument is an assertion that a given set of statements, so let's say we have n number of statements, if that implies another statement, that is when we have an argument. In other words, an argument is an assertion that the statement S follows from the statement the S1, S2 all the way up to Sn. That means we have n number of statements. So here these n statements are actually referred to as the hypothesis or also known as premises. And the statement S is called the conclusion. So in a logical fashion, if you want to write it, an argument will then be denoted by S1, S2 all the way up to Sn, S. So here this is the premise or the hypothesis, and based on this particular hypothesis, we have a conclusion S. An example would be, let's say we have statement 1, all scholars are absent-minded. So this is a hypothesis. Then we have a second hypothesis or a second premise that John is a scholar. Then we are gathering the conclusion from these two statements as that John is absent-minded. So this is how an argument looks like. Now we will next talk about valid arguments. Now the reason we will talk about valid arguments because the conclusion of any given argument may or may not be true. If the conclusion of an argument is true, whenever the hypothesis S1 and S2 are true, then that is when we get is a valid argument. So let's talk about the definition of a valid argument. So we can define a valid argument as an argument which is defined by S1, S2 all the way up to Sn. That means a number of hypotheses, and the conclusion is S. Then this is said to be a valid argument if the conclusion S is true whenever all the hypotheses are true. So we'll state an algorithm to determine to check whether if a given statement is valid argument or not. So what we'll do in step number 1, we'll begin by constructing a truth table, and in this truth table we're going to show the truth values of all the hypotheses including the conclusion. Now what we'll do, there will be particular rows where all the hypotheses are true. So all the hypotheses, that means all the statement S1, S2 up to Sn, these are going to be true. We are only going to consider those rows, and such rows are referred to as critical rows. Now let's suppose there are no such rows where the hypotheses are not true at all. Then in that case the argument will be automatically considered as invalid argument. However, in most of the case we are going to find some critical rows, and now once that we have a critical rows, all that we have to do is check for the truth values in each of the critical rows. Then the condition is that if the conclusion is true, we have a valid argument. That means if the hypotheses are true and that follows that the conclusions are also true, that we have is a valid argument. And if there is at least one critical row, let's say we have found 4 critical rows, of them 3 are correct, 3 have a proper conclusion, true conclusion, whereas the 4th one, the conclusion is false, then the argument will become automatically invalid. So let's work on few numerical, and this will help us understand how to check whether if a given argument is valid or not. So here we have example number 1. So we are given 2 statements P and Q, and we have to examine that this particular argument S1, which is the hypothesis, and S is the conclusion, is a valid argument or not. It is given that the hypothesis S1 is, this is S1, this is the P, and the conclusion is given by the disjunction P or Q. So first we have to state the truth values of P and Q. So let's consider the possibilities. Both are true, one of them is true, and both of them are false. Now using this particular truth table, we list down all the truth values of the hypothesis. Since hypothesis is the truth values of P, so this will be true, true, false, false. Now the conclusion is given by P or Q, so that will be true when at least one of them is true. So we have true, 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 and the final truth value will be false. Now the next task will be to find out critical row. Critical row is when the hypotheses are true. So that means we only have two such critical rows. So this is one critical row and this is the second critical row. Now for the first critical row, we have to see if the conclusion is true. So okay, find this passes the validity test. The second critical row also have a true conclusion value. So that means this entire statement, the hypothesis is P and the conclusion is the disjunction P or Q is a valid argument. Let's move on to the next problem. So again, here we have two hypotheses. The first hypothesis is given by P or Q and the second hypothesis is given by not Q, negation Q. So using these two hypotheses, we need to check whether if the conclusion P and not Q, if this is a valid argument or not. So first thing first, we list out the truth values of P and Q, all the possibilities. So we have false and false. Now there are two hypotheses. So the first hypothesis is S1, which is P or Q. So we have to take the disjunction between P and Q. So this will be true when one of them is true and false when both of them are false. And the second hypothesis is S2, which is negation of Q. All we have to do is flip the truth values. We have false, true, false, true. Now the conclusion is given by taking the conjunction P and not Q. So here we have not Q value. So we will take the conjunction of P and not Q. So that will be true, false. So this is going to be false. So we have true, true. This is going to be true. False, false is false. False, true is false. Now, all we have to do is now consider the hypothesis. Now look at the first row. So we have true, false. So we are going to reject it because both of them has to be true. So we have both of them are true. So this is like one critical row. Then we have true, false. So no need to check this. False, true. No need to consider these two rows. So we have one critical row, and for this particular row, we have a truth at the conclusion which has a truth value true. So since this is true, so that means the hypothesis is true, and the following conclusion is also true. So that means our given statement is valid. It's a valid. We can say it's a valid argument. Let's move on to the next problem. Problem number 3. So here we have two hypotheses. It's a conditional statement for both S1 and S2. So, and the conclusion is the disjunction P or Q. Let's begin by listing out the truth values of P and Q. So we start with the first hypothesis, S1, which is the conditional statement if P, then Q. So if P is true, then Q is true. So this is going to give us a true truth value. If P is true, but Q is false, so this is going to give us a false truth value. If P is false, but Q is true, so this will be true. If P is false, then Q is false. So this is a true truth value. Let's list out the truth values of the second hypothesis. If Q, then P. So we have if true, then true. So this is a true statement. If false, then true. So this is a true statement. If we have a true truth value, then false. So this is going to be false. And finally, if Q is false, then P is false. So this is a true truth value. Now we'll find out the truth value for the conclusion, which is P or Q. So this is going to be true when one of them is true. And it will be false when both of them are false. Now the next task will be to find out the row where both the two hypotheses are true. So we have the first row. So this is critical row number 1. Then we have the last row. Here also we have critical row 2. Now next thing that we need to check is for that particular critical row number 1, what is the conclusion? Is it true or false? It is true. So this passes the test. But for the second critical row, here we see that we have a false conclusion value. Since we have one false conclusion value, so this means this is an invalid argument. Let's move on to the next problem. So we have statement S1, which is if P, then Q, and statement 2, which is P, and statement which is S, the conclusion is given by Q. So we state the truth value for this conditional statement if P, then Q. So this is going to be true, false, true, true. Then P, this is statement number 2, which is simply the truth value of P. So that will be true, true, false, false. And the conclusion is given by the truth value of Q. So that will be true, false, true, false. Yeah, what we will do, we'll find a critical row. So this is one critical row because both the two hypotheses are true. Then we do not have any other row where the hypotheses are both true at the same time. So that means there is only one critical row, and for that particular critical row, the conclusion is also true. So that means this is a valid argument. So let's move on to the next problem. So here we have three statements, P, Q, and R, and we have to examine if this particular argument is valid argument or not. So here we have three hypotheses. The hypothesis 1 is P or Q, the disjunction. Then hypothesis 2 is a conditional statement, if P then not Q. And hypothesis 3 is the conditional statement, if P then R. And the conclusion is given by R. So let's begin by listing out all the truth values of P, Q, and R. So that will be. Now let's come to the first hypothesis, S1. So S1 will be P or Q. This is disjunction. So this is going to be true. At least one of them is true. So the first four rows will be true. Then we have false, true. So this is true, false, true. This is true as well. So we have false, 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 false. So both of them will be false. Now, hypothesis 2 states that if P, then not Q. So that means we also need not Q. So not Q will be simply flipping the value of Q. So this will be false, false, true, true, false, false, true, true. Fine. So let's find the conditional statement. If P, then not Q. If true, then false. So this is going to be false. If true, then false. So this is going to be false. If true, then true. So this is true. If true, then true. So this is true. If false, then false. This is true as well. If false, then false. This is true. If false, then true. So this is true. And if false, then true. So this is also true. And coming to the third hypothesis, P, if P, then R. So we have to consider row 1 and row 3. So if true, then true. So this is true. If true, then false. So this is false. If true, then true. This is true. If true, then false. This is false. If false, then true. So this is true. If false, then false. So this is true. If false, then true. So this is also true. And if false, then false. So this is also true. And conclusion is simply the statement which is the R. So R will be simply the truth values of R. So that will be true, false, true, false, true, false, true, false. Now our next task will be to figure out the critical rows. So the critical rows will be the one where all the hypotheses are true. So this is the first critical row. Then we have one more critical row, and we have a third critical row. So here we have three critical rows. So for the first critical row, we have the true conclusion. So this is fine. So for the second critical row, the conclusion is true. So this is also fine. But for the third critical row, the conclusion has a truth value of false. So this does not pass us the validity test. So we will say this is an invalid argument. So we have example number 6. Given three statements P, Q, and R. So we have to examine that this particular argument is valid argument or not. So here we have three hypotheses, S1, S2, and S3, and the conclusion S. So since there are three statements P, Q, and R, so let's list out all the possible truth values. So we have. Now, in order to find out the hypothesis, we need to find out the negation of Q. So that will be, then we take the conjunction P and not Q. So P and not Q will be true and false. So this is going to be false because in the conjunction, we only have a truth value when both of them are true. So we have true, false. So this is false. True, true. So this is true. True, true. This is true. False, 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 false. Now we work with our first hypothesis, which is S1. We have P and not Q, then R. So we have if false, then true. So this is true. If false, then false. So this is true. If true, then true. So this is true. If true, then false. So this is false. If false, then true. So this is true. If false, then false. This is also true. If false, then true. So this is true. If false, then false. So this is true. Coming to the second hypothesis, we have the disjunction P or Q. So this will be true for any one of them is true. So we have true, 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 true. Then we have true, true, false, false. Coming to a third hypothesis, if Q, then P. So we have if true, then true. So this is true. If true, then true. So this is true. If false, then true. So this is true. If false, then true. So this is true. If true, then false. So this is going to be false. If true, then false. So this is going to be false. And for the last two row, if false, then false. So this is going to be true. Now, for the conclusion, there's simply the truth value of R. So this will be true, false, true, false, true, false, true, false. Now, what we will do next is list out all the row, the critical row where the hypotheses are true. So we have the first row. This is the first critical row. Then we have a second critical row. All of them are true. Then we have third critical row. Then we do not have any critical row. So here, the conclusion of critical row 1 and critical row 3, they are true, but the conclusion of critical row 2, that's false. So this is going to be an invalid argument. Let's move on to the next problem. So we'll test the validity of this particular argument. So let's start. We have three statements here, P, Q, and R. So their truth values will be, let's list out all the possibilities. Now, in order to find out the hypothesis, we need few statements that we need to take care of. For instance, we need to find the truth values of negation of R. So negation of R will be simply flipping the truth values of R. So we have, now we take Q or not R. So this will be true when one of them is true. So true, false, true, 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 true. Both of them are false. That will be false. False, true. So this is true. True, false. So this is true. True, true. So this is true. False, false. It will be false. False, true. So that is true. Then we take the conjunction P and R. So this will be true only when both of them are true. So true, true. We'll find out if there's any other possibilities. So we have true, true. So in rest of the cases, it will be false. Now let's come to the hypothesis. So our first hypothesis is the statement 1. So if P, then Q or not R. So we will consider this and this. So if true, then true. So this is a true statement. If true, then true. So this is true. If true, then false. So this is a false statement. If true, then true. So this will be true. If false, then true. So this is true. If false, then true. So this is true. If false, then false. So this is true. If false, then true. So this is true. Then we have if Q, then P and R. So here we'll consider Q and P and R. So okay. So if true, then true. So this is true. If true, then false. So this is false. If false, then true. So this will be true. If false, then false. So this is true. If true, then false. So this is going to be false. If true, then false. So this will be false. If false, then false. So that will be true. If false, then false. This will be true. And finally, we come to the conclusion. So that will be if P, then R. Fine. So this will be if true, then true. This is true. If true, then false. So that will be false. If true, then true, this will be true. If true, then false, so this will be false. If false, then true, so this will be true. If false, then false, this will be true. If false, then true, this will be true. If false, then this will be true as well. Now we check for the critical rows. So here, this is one critical row. Then we have another critical row. Then we have third critical row, and there will be 4. So that means here we have 4 critical rows. C1 is fine, C2 is problematic, C3 and C4 are fine. Just because of C2, this entire argument is an invalid argument. Let's move on to the next problem. So let's try out example number 8. So here we have the given statement P or Q or R. Hypothesis 2 is not R, and the conclusion is P or Q. So we'll first, since there are 3 statements, so first we will list out the truth value possibilities for P, Q and R. So we have, so first we consider junction Q or R. So this will be true when at least one of them is true. So true, false, true, false, true, true. Both of them are false, so this will be false. One of them is true, one of them is true, one of them is true. Both of them are false, so this is false. Now we come to hypothesis 1. So this is the first statement, P or Q or R. So we'll consider column 1 and column 4. So true or true. So this will be true, true or true, true, true or true, true, true or false, true, false, true. So this will be true as well. False, true, true, false, true, true. Both of them are false, so this will be false. Hypothesis 2. So this is negation of R. So this will be simply flipping the truth values of R. So we have false, true, false, true, false, true, false, true. And the conclusion is the statement P or Q. So we have true or true. So this will be true, true, true. This will be true, true, false. So true, true, false will be true. F false, true. So this is true, false, true. This is true. Then last 2 row will be false. Now we'll look for critical row. So this will be critical row number 1 because both the hypotheses are true. Then we have the second critical row here. Then we have one more critical row. So there are 3 critical rows, and here we see that the conclusion is true for each of the 3 cases. So this is going to be a valid argument. Now there is also an alternative way to test the validity of arguments. So that would be if we consider all the hypotheses and take the conjunction, and we use the conditional statement that if the conjunction of all the hypotheses, then the conclusion S is a tautology, then we will say that our given argument is valid. So the algorithm will be to construct a truth table for the statement, and we'll find out the truth value for this conditional statement, and then we are going to check the last column of the truth table which we constructed in step number 1. If the entire column has truth value only true, that means all of them are true, then the given argument will be valid. Otherwise it will be an invalid argument. So let's try this particular algorithm. So here we have 2 statements P and Q. So the truth values will be the possibilities. Both of them are true, one of them is true, or both of them are false. Now we consider the first statement or the first hypothesis P or Q. This is disjunction which will be true only when at least when one of them is true, or else it will be false. Then statement number 2 or the hypothesis 2 is negation of P. So this will be false, false, true, true. Then what we do, we consider the conjunction of hypothesis 1 and hypothesis 2. So this will be true only when both of them are true. So this is the only case when both of them are true. Now else it will be false. Come to the conclusion S, which is simply the statement Q. So Q will be true, false, true, false. Now what we'll do, we'll consider this column and form the conditional statement. If false, then true. So this will be true. If false, then false. This is also true. If true, then true, this is true, and if false, then false, this is true. So we see that all the truth values are true, which is a tautology. So in this case, we say that the given argument is a valid argument. Let's do another problem. So here we have three statements, P, Q, and R. So, and we are provided with two hypotheses. So let's test the validity of this particular argument. First, we'll begin by listing out the truth values or the possibilities of P, Q, and R. So that will be, now coming to hypothesis 1, which is a conditional statement. If P, then Q. So we'll consider this two column. If true, then true. So this will be true. So this is only false if we have antecedent is true, but the consequent is false. So we'll look for this particular case, and this is the only time when this is going to be false. In the rest, it will be true. Then similarly, we will consider the conditional statement. If P, then R. So this is going to be false only when the antecedent is true, but the consequent is false. So we have one here. So this will be a false statement. So we'll look for another case, a true, false. So this is also going to be false. So in rest of the case, it's going to be true. Then we take the conjunction of hypothesis 1 and hypothesis 2. So this will be true, true, false will be false, false, true will be false, false, both true. So they are true, 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 true. Now we have statement S, which is the conclusion. If P, then Q and R. So here we also need to find out Q and R. So Q and R, this is the conjunction between Q and R. So this will be true, true, false. So this is false, false, true. This is false, true, false. So this is false, true, true. So this is going to be true, true, false. So this is false, false, true. This is false, and we have both are false. So this will be false. So let's construct the truth values of this conditional statement. If P, then Q and R. So we have if true, then true. So this is true. If true, then false. So this will be false. If true, then false. So this is going to be false. If true, then false. This will be false. If false, then true. This will be true. If false, then false. This will be true. And the rest will be true as well. Now, finally, what we do, we'll find the conditional statement between these two. So if true, then true. So this is true. If false, then false. So this is going to be true. If false, then false. So this is true. This is true. If true, then true. So this every case it will say we have a true truth value. So we'll say this is a valid argument. Let's move on to the final problem. So here we have two hypotheses. If Joe is not in team A, then Buck is in team B. Hypothesis 2, if Buck is not in team B, then Peter is in team A. And the conclusion is that Peter is in team A or Buck is not in team B. So for this, we are going to consider three statements, P, Q, and R. So here P is the statement that Joe is not in team A. The statement Q is Buck is not in team B. And R is the statement Peter is in team A. So if we use this statement, then RS1, that will become if Joe is not in team A, Joe is not in team A, then Buck is in team B. So here Buck is not in team B is Q. So since Buck is in team B, so this will be not Q. Then we have the hypothesis 2. If Buck is not in team B, so this is Q, then Peter is in team A. So this will be R. And then we have our conclusion. Peter is in team A. So this is R. Or this is a disjunction. Buck is not in team B. So this is Q. So let's construct the truth table. So first we list out all the possibilities for PQR. Then we need to find out the negation of Q. So that will be flipping the truth values of Q. So this will be false, false. So we go to statement number 1 or the hypothesis number 1. If P, then not Q. So this is true. If true, then false. So this is going to be false. If true, then false. So this will be false. If true, then true, this will be true. If true, then true, this will be true. If false, then false, this will be true. If false, then false, this will be true. If false, then true, this will be true. If false, then true, this is going to be true as well. Then we go to the second hypothesis, if Q, then R. So if true, then true, so this will be true. Now we take the conjunction between the two hypotheses. So conjunction will be true only when both of them are true. So this will be the case when both of them are true. So this will be true, 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 and rest of them will be false. Now we come to the conclusion, which is the disjunction between Q and R. So this is going to be true when at least one of them is true. So the first case will be true, second true, true. This will be false because both of them are false. So, and the last also, this is false, and all other case it is going to be true. Then we finally find out the conditional statement. If S1 and S2, then S. So this will be if false, then true, this will be true. If false, then true, true. If true, then this will be true as well. If true, then false, so this is going to be false. If true, then true, this is going to be true. If false, then true, this will be true. If true, then true, this is true. If true, then false, this is going to be false. So here we have two false values, so this is going to be an invalid argument. So this is how we can check the validity of given arguments, so using algorithm